Hello everyone, good morning. Thank you for coming to my talk. I'm really glad that you are here and I hope that we are going to have a wonderful experience. I'm Arian and today we are going to write some contracts. As we know, performance is one of the main staples of C++ and I would say the main reason of why we write the code. And for that reason, I made sure that I have a super catchy title on in order to draw your attention. But for the purposes of this talk, I would like you, albeit for a short moment, to completely forget the title. So, what I noticed during my lifetime is that with communicating with people or during getting a new job, I was always presented with different kinds of contracts that I had to sign. As being a technical person as I am, during my sleepless night, instead of counting sheep, I was trying to solve this problem. And I came to the conclusion that everything that we do in our lives is sort of an arrangement or a contract. As I took a deep dive to the problem, I noticed that the crux of all of these contracts is just generating new information or exchanging existing information. And I came to the conclusion that the C++ itself, as a programming language, is a contract that is given to us in order to express ourselves. Therefore, instead of having a usual arrangement where I am the presenter of the talk and you the audience, I would like that for all of us to put on the hat of the lawyer and let's start writing together some contracts in order to supercharge our intra-process communication programs. So let us set some rules into place first. IPC stands for Intra-Process Communication. Programs stand for software running in a constraint environment. I would call them embedded devices, but for some people, embedded devices would be teeny tiny devices that have barely maybe 64 megabytes of RAM. But in our case, what we are going to do, we are targeting those embedded devices that have at least 512 megabytes of RAM. That means the ability to run the full Linux kernel and use all the facilities that Linux provides. As for the CCI, it stands for contract, concept, and implementation. And this is the pattern that we are going to utilize in order to supercharge our intra-process communication. What is the problem that we are trying to solve with an IPC? As we know, images are widely available and they are used in different kinds of applications. And one of the basic operations that we can do in the image is just basically extract the image channels, the color channels. In computer world, images are made from three main colors. It's red, green, and blue. And we would like to have a service which allows us to extract a particular channel from image. For intra-process communication, we are going to use a facility called dbus. That is just an abstraction written in C, which sits atop upon the Linux sockets that introduces some abstractions like, for example, bus, service, object path, interface, and methods, which makes our programming more easy. In order to explain to you what these mean, I will take a simple analogy. For example, a bus, you can think all of the network communication that happens. For service, you can think of a process group that live under one single parent, for example, under PID 1. For object path, that could be your executable. For interface, it is a struct or C++ class, and for method name are just the methods that belong to this particular class. So the people who have designed the systemd have provided us an interface in order to achieve this, and we are going to use this contract, which is a low level, in order to be able to extract the specified color for the image that we upload. In order to do that, first we need to define a struct, which is called error, and we use a macro definition, and we don't have idea what is going behind, but that's how the interface is working. That's how we are applying the contract provided by the systemd. Then we need to declare a pointer of type sdbus message. We need to declare itself bus as sdbus pointer. In order to store the results, whether it was successful, we just declare a constant int32. And when the methods are executed from the dbus, if we want to get the results back, we just store them in a variable called r. Then for input parameters, we are going to use two static strings. First one is just going to be the file path to the image that we want to perform this operation. The second one is we provide a path where we would like to save a new image with the extracted channel. And with the unsigned int8, we are just telling that we want to extract a particular channel. In our case, with number 1, we represent the green channel. And in order to do that, we call the method called sdbus call method, where, as you can see, we provide a huge number of input parameters. We have bus, then we have 3 constant strings, then we have the method name, which is explained as an extract channel. We provide the reference to the address, actually, to the error message. We provide something in the constant string with these weird letters called OOY, and we provide our 3 input parameters. So without further ado, I would like for you to raise your hands who thinks that this is a wonderful interface to call a function. Well, you think, or would you like to elaborate more? Why you think this is and like wonderful, basically. Easy to use and easy to access, not to make mistakes. Well, as I predicted, no one would raise their hand, so I'm going to ask the opposite. Who thinks that this is not a good interface that could lead to disasters? Everyone, so it's obvious. I think that by applying CCI pattern, we can make this interface much better. Because with this interface, I see problem with every possible parameter. Let's start, for example, from bus. Bus, it's a pointer, and in the C language, we need to know that we need to manage its lifetime, so the creation and the destruction. No matter how experienced a programmer you are, when you're tired or when you didn't get enough coffee for the day, you will forget to use free. That happens, it's quite normal. Then we have a constant string, which are 3 constant strings, which specify the service name, object path, and the interface name. And we see that are very particular in the way that they specify. The service name uses dots, and then the object path uses forward slashes. And if you make a mistake or you don't follow the convention, the code compiles, it works correctly, but when you go to your embedded device and flash it to use, you run to a runtime error. So for these 3 parameters, we have some runtime errors that we need to take care of. And the biggest problem that I see is that for the input parameters that you have to provide, in our case being file, save path, and channel, you need at the same time to provide their signature. So if you didn't write OOY, which is the signature of these 3 input parameters, the code would compile, you would get 0 complaints, but when you would go and flash your device or embedded device and try to use your code, you would be met up with an error message. And now imagine that your embedded device is living in the car, you compile the code and you go to your car in 10 minutes and you hope for your program to work and you just run in runtime error, a big waste of time. So what we are going to do, we are going to create a contract which specifies the characteristics of data type. Then we are going to create a concept which enforces the contract. And finally, we are going to create an implementation which is constrained by the concept. So I have just like a general questions. Who of you likes writing contracts or reading through them? I guess nobody. Who hates going through long contracts and trying to understand them? I see some hands up. So don't be bothered. I try to make these contracts as easy as possible. So we are just going to define some vocabulary, which will serve us during our talk in order to understand what we are actually doing. So contract is just a bunch of papers that you get. And our bunch of papers, in our case, will be represented either with a struct or a C++ class. Inside the contract, you have many paragraphs which explain the conditions or what is going to happen with you when you sign a contract. So our conditions in our case are just going to be the members of a type or the member functions. They are going to be templated, and as for the type, they are going to take the type upon which we are applying the contract. And most of them, unless specified differently, they will always have a Boolean as a return type. So either it's satisfied with true or it's not satisfied with false. So what I wanted to do with the bus object, I wanted to convey through the contract that I wanted to be inside a unique pointer, which gives me the guarantee that the lifetime, when it's created and going out of the scope, will be destroyed properly. And I want to make sure that I only have 1 instance of bus. Because again, I am repeating myself, if you happen to create 2 bus instances, the code will compile correctly, but when you go to the runtime, it will crash because you cannot have 2 bus instances. I created a simple type def, which called sdbus inner type, which is unique pointer of type sdbus, and for its destructure, the second parameter of unique pointer is just the function sdbus unref. And our contract is quite simple. It has only 1 clause, making sure that it's a unique pointer. After reading the whole of the contract and coming to the last page, we are usually met with a dotted line saying to write our signature and to put in the date that we accept the conditions. Concept serves the same thing. In order to enforce the clauses of the contract that we made, we create a concept which again takes it's a templated type, which takes the type upon which we want to sign the contract. In this case, we just make sure that the type that we are provided, it's a unique pointer. And now we are at the fun part. We can start with the implementation. We can use the facility of C++ that when we declare a templated parameter, instead of writing type name, we can actually provide the concept. So it means we are enforcing our contract. We can also provide the default value which says it has to be a SD-bus inner type. So this also makes us easier to apply this parameter because you have consistency. You start with the contract, then the concept enforces the contract, and through the implementations, both of them are mentioned one more time. So it provides a sense of the consistency, and we just create a simple dbus object using the constructor that is provided. Now we can create the type itself, and we utilize the function that we created on the previous slide. For the purposes of dbus, I also need to get the raw pointer inside. That's why I created the PTR. And I also need to get the address of it in order to pass to a function called sdbus createBus. And I created two operators just in order to create a useful interface when the users use it, so they don't need to have to worry about whether I need to get the reference or I need to get the address of a pointer. So the first one is basically just the overloaded operator of small brackets, and the other is the implicit cast to the pointer. And in order to be used to in functions to check whether everything is correct, I just create a new concept which makes sure that the type that we are provided is the same as the sdbus inner type. This is as far as the bus object is concerned. We are going to do the similar thing for message. So we create a type def. We want to make sure that we have only one instance of message inside a particular scope. We define the contract that we want to be the unique pointer. Then in order to implement, to sign our contract, put our signature at the dotted line, we create a concept. And we specify the clause of is it unique pointer inside sdbus message contract. It's also very similar how we create the helper function. And in the end, the implementation is the same as for the bus object. Here, we make sure that when we use an sdbus message type inside of a function, which we will use later at sdbus call method, we make sure that all the constraints have been satisfied. Now, I would like to ask a question. What is the part that you hate most when reading the contracts? Because I have one part that I hate a lot. Or you just make sure that you skim. Is there anything that you hate particularly in contracts?
Fine print.
So the gentleman there says that he hates fine print. Well, I could agree that I hate that too, but the part that I hate the most are the addendum, when it's a contract on top of the contract. But unfortunately, for this, we will have to do that. And I promise I will try to make this as easy as possible. The reason why we'll have to do a contract on top of the contract, the addendum, is because of the specifics of the error type. You notice in the previous slide when we created an error object that I provided a macro definition. So it was not object construction and so. When you right-click it and you go to the definition of the macro, you see that it actually creates an object of a specific type. By investigating further, you see that it creates an object which takes 3 input parameters. First and the second one being a 0, which is cast to void pointer, and the third one being a standard int. And I see this as a code smell, and I wanted to make sure that first I will deal with the inner type by creating a contract, and then in similar way as with message and bus, create a contract on top of it to make sure that it's consistent with the interfaces that we did until now. So our contract is made here from 2 clauses, even though there are 3, but because the first and the second one are connected, I will say that is one clause. It makes sure that it has an overloaded const-char operator. And this will be useful when we create the object. We will be able to provide an empty string, an empty constant string. How this works is that first it is evaluated to false, and then if the second condition is satisfied, it is automatically evaluated to true. If it does not work, then because of the substitution failure is not an error, it reverts back to the first one that is evaluated to false. And the second one is very simple. I just wanted to make sure that this object is trivially constructible, and I use the C++ facilities that are provided. Mainly the function is constructible. Now, in order to enforce our contract and its clauses, we create a concept. It's very nice because when you want to make sure that more clauses are included, we can use the logical AND operator. And we can also use all types of logic actually here. So if we want to make sure that maybe one of two is satisfied, we can use the logical AND, logical OR. But in our case, we want both of them to be satisfied, and that's why we use the logical AND. Now we create our type, and we make sure to have our operator, the operator overload of const-char star. And we basically just return a null pointer because in the beginning we just want to be initialized as a null pointer. So I would like to ask a question. If we didn't have the overload const-char star, what would happen if we didn't overload here? It wouldn't fulfill the contract, and the compiler would complain. It's saying this concept has not been satisfied. So all of this, what we are doing, we are trying to make sure that we are steering the programmers in a particular way on how to work. So the gentleman there said that if we don't have the const-char operator overload, the contract would not have been fulfilled. Now we create the contract on top of the contract to make sure that is consistent with the interface that we are starting from the beginning. Here, I wanted to make sure that fields have a particular name when the object is initialized, because I didn't want to deal with the zero point casting of a zero to void pointer and not knowing what is actually happened. So I wanted to give the programmer the information that those two fields actually have a meaning, they do something. So I created a clause which checks whether particular struct has a field called the name. And I also create a clause which checks whether a particular struct has a field called description. And I made sure that both of those types are strings. So this is actually what this contract does. In order to enforce that contract, I, again, applying a concept, and I put it in the clauses that it has a field name, is of type string. It has field called description, and that field is string. And I connected all of them with AND logical operator. And now things go back as we were previously for SD-bus message and SD-bus object itself. So we create a helper function. We can also use no discard, which makes sure that we need to grab the return value. This is also a type of actually enforcing something through contract. And when we create the object, we just we default construct it, and we have the fields specified there. Here is the implementation of the SD-bus error type itself. We make sure that the name and the description are started with empty strings. Then this, what it does is that calls the overload, the const-char star overload, and it returns a null pointer. So we made sure that when you provide an empty const string, that it gets converted to a null pointer behind, as it should be. And here it is the SD-bus error object itself, something that we are going to use in the function called SD-bus call method later. And as to be able to use it in the function and make sure that all constraints are satisfied, we just create a concept making sure that the type that we are providing is actually of a SD-bus error type. Now I would like to do something a little bit different. We made sure that bus object, message, and error satisfy the conditions of being of a particular type. We made sure to manage their lifetime properly, But now, when we arrive at the service name, you notice that when we call the method as dbus call method, you notice that it had to be written a particular way. The service took dots, whereas the object path took forward slashes. So I wanted to make sure that when a programmer provides a service name, to provide it in such a way that I can eliminate runtime errors. So I wanted to tell them that when they don't provide the correct service name as specified in the debug specification, they are met with error. The code does not compile, and they are state of going to flashing the device and checking whether there's error in runtime. So I created 2 global variables, made sure that the service name does not have more than 30 characters, and that the service name starts with com. Then creating a contract was easy. We had only to use 2 clauses. And you notice that it's the first time that we are using a clause which does not return a Boolean, but it returns actually the size of the constant string. So this is like an exception, because in the beginning I told you that all of our clauses will turn Boolean, but you are not forced to do that. According to your needs, you can update your contracts to return different types. In our case, we want to make sure that we get size t. So the first clause is whether the max length is satisfied, and the second one is whether it starts with the constant string that we specified above. Now this is a helper function which makes sure that the service name is of a max length. It takes the const char and returns the length. This is a C++ and I think facility which gives us the possibility of the compile time just to get the length of constant string. And it's very simple, so you just return the length. This one is a little bit more convoluted. I used std span from C++20 in order to get the first 30 characters, 3 characters. I iterate, and if all of them are as specified in the constant string, it returns true. If either of them fails the condition, then we return false, because we didn't start with com in the beginning. In order to enforce the contract, we have again the same story. To put the signature, we create a concept, and we enforce these 2 clauses. And in the end, we create a helper function which gives us creates us a service name. And in order to utilize this function, I'm creating a helper macro which is called service name, and which actually calls the service name inner and provides those 2 helper functions for the length and whether it starts with com. This facility, if we modify our function, instead of taking a Boolean u, we modify with taking a variadic template, then we can provide as many conditions we want inside our macro, and this is something that we are going to do later. So we are going to expand this concept, but for services name purposes, I think it's enough just to make sure that these 2 conditions are satisfied. And the same story again. In order to enforce it as inside the function as a function parameter, we make sure that the type that we provide is same as the service name type. Now, you notice that when we call the sdbus call method, we had the constant string signature with those interesting letters inside OOY, and then we had the input parameters. Now I want to create a contract which gives me the possibility to only provide the type, and the signature is generated automatically. So the programmer doesn't have to worry whether the input signature was written in the correct order or whether all the parameters were included. So this is something that makes the thing automatically. In order to do that, I created a helper structure called dbus path, which again takes the length of the string and puts the value of it inside the constant string. And as a helper variable, I just tell it that the signature is O. I do similarly for the unsigned int 8, and I put it inside the unsigned int 8 value, and for the signature, I provide Y. Now this is the fun part where all of the magic happens. I utilized 2 concepts. So just imagine those of a contracts that I have to give multiple signatures in. So it's mimicking the same thing. The first concept, which is any of, makes sure that the type that you provided, it is any of the possible types that can exist. So for example, you provided a dbus path. It checks whether it is a dbus path or dbus uint8 or dbus new in 32. So just make sure that you provided one type which is in the scope of the supported scope of the type family. And in the end, to make sure that all of the types that we provide in, we just create a concept called dbus supported types, which calls the previous concept any of and ties them logically with the AND operator. And of course, we can never get rid of the macros. In order to provide a consistent interface, I just defined 3 macros for red channel, green channel, and blue channel. And they are just types of dbus assigned int 8 with different initialization values. OK, so before you take a deep dive in, who of you thinks that this function signature is very convenient to use? No one. Who thinks that this is actually a very convoluted function signature to use? So I see some hands. So what did we do until now? We created all of those contracts, and instead of simplifying, we made it more complicated. I guess it seems so when we look at this slide, but I promise I will try to convince you that it's not this way. So what this function actually does is just it returns the lower level sdbus call method and calls all the parameters as it did before, but this here is just, instead of providing the const signature, the signature is taken, it's unloaded, and then it's casted to C constant char. But now I would like to ask you the same question again. Which of these two interfaces utilizes CCI, and which of these two user interfaces does not utilize CCI? The one on the right is the CCI. That's correct. So this is actually what you will get to see is the interface when you use the dbus. You are not going to see the function signature. So let's go back again. Are you now more convinced to start utilizing CCI? This is not what you're going to see. It's actually, when you use the interface, is the thing on the right that you're going to see. So I hope that I managed to convince you a little bit that CCI is one of the possible ways of how you can reason about the program. So even though the interfaces of these functions seem very similar, there are quite huge differences. On the right, which utilizes CCI, we make sure that bus's lifetime is correctly managed. So when it goes out of the scope, it gets destroyed automatically, whereas on the left, that is not the case. We make sure that service name does not pass more than 30 characters, and it starts with com. Similar to the object path, we can make sure that it started with a /. And also we can put limits and constraints on interface name, on the method name. Furthermore, I made it more easy that you don't have to worry whether I have to provide the address of the object or I maybe need to cancel something else. All the input parameters that are using in the raw form. Whereas on the left, you need to take the address of the error, you need to take the address of the message. And finally, I got rid of the problem with the function signature. You here just provide the parameters, which is dbus path, and red channel, and you don't have to worry about whether the signature was correct. So as a programmer, when you would use the dbus with CCI pattern, the interface that you would be dealing with is the interface on the right. And you will have compiler as your friend supporting you that if you don't provide the parameters correctly, under no circumstances they would compile. So you would get a nice clean error explaining that a particular constraint was not satisfied, which saves you a lot of time and at the same time actually teaches you how to use the interface properly. So as I mentioned, performance is one of the main staples of the C++. We wrote a lot of contracts and the concept. So created a very simple program which creates a dbus unsigned int 8 blue channel. It is a constant expression, and in the main, I just return its value. So how many assembly line of code do you think that this code will produce? Taking into account that all of the contracts and concepts were utilized in order to create this particular type. So to make it easier, who thinks that it's going to be more than 100? No. Who thinks that it's going to be less than 100? Yeah. Who thinks that it's going to be less than 5 lines? Yes, so that is correct, because everything being evaluated at the compile time, the output that we get is just 2 assembly instructions. Okay, what we did until now is that we utilized CCI in order to wrap a lower level facility. Now let's take this and make it in more general and ask a general question. Is it possible to utilize CCI and design a class starting from the start, like just simply by getting your system requirements and description? I think it is possible to do that, and I would like to try and do it together. So I received a task today, and I have to design a class called person with following characteristics. It has name, surname, age, expenses as attributes, has getters for each of the attributes. I will agree that this is one of the enter patterns, but I guess it's not the first time that we received requirements that are not 100% clear and satisfied, but for our purposes, we will assume that our class has getters. Then the attribute name has a minimum length of 3, maximum length of 14, and has to start with A. Even though it seems like a very unreasonable requirement, but as I said, it's not the first time that maybe during our jobs we get unreasonable requirements to deal with. The things that we are going to do differently compared to the dbus example, we are going to create some helper functions, which will help us to more easily express our intent. I know that in the standard exists a function called logical not, but I could not get it to work, and I got angry after 1 minute, so I decided that I'll just create mine for these purposes. What it does is just takes a Boolean value and returns the reverse of it. So true becomes false, false true. Very simple. Here I create a helper function which makes sure that a particular field is inside of a class. It's called field checker, and it uses the function of standard library, which is called isMemberObjectPointer. So if you have a class which has a member A, that will evaluate to true, but if it doesn't have B and it requires to have B, it will simply evaluate to false. Similarly, I did this for the functions. So this makes sure that it checks whether a particular function exists inside the class, and it works in a similar way as for the fields. The only difference is that instead of looking for whether a particular member exists, it checks whether a function pointer exists. So I'm going to create now the person types. The attributes are going to express them as types. So we put name to be of a type std string. We put the surname to be also of type of std string. We declare age to be of type int, and expenses, we would like to declare them as double. It makes sense for the expenses to be double. And now I guess we are ready to start writing our contract. So the first clause that we want to write, we want to make sure that our class person has those particular fields. So we call the field checker contract, and we look at the clause called has fields. We provide t as a type. In our case, it's going to be person, and we check whether we have name, surname, age, and expenses inside. Similarly, we do the same for the functions. We check whether it has the getters called get name, get surname, get age, and get expenses. And finally, we want to make sure that the person is not trivially constructible, and that is where we use our logical not helper function that we defined, and we just place the return value inside the is not default constructible. And now, in order to enforce our clauses, we create a constant, very similarly how we did before. Here, what C++ provides as a facility is that when you provide the type name, we can use any variable placeholder, and just to drive the point home, we are going to name it person. So when we declare the concept, we can read it in a very English-like language. So we have a person contract, which is applied on person, and the clause that we want is whether the fields exist. That is what we query. Then we want to make sure that inside the person contract, when we look at the person, we want to make sure that a particular functions exist. And finally, inside the person contract, which is related to person, we want to make sure that it's not default constructible. And these clauses are those clauses that have to be valid at the same time, and that's why we tie them with logical AND. Here we make sure that the types that we provide inside the person constructor are of the type name, surname, age, or expenses, similarly as we did to the dbus types. And we use those to help or facilitate any of and supported types. And in order to make sure that it's valid, we create just a very small concept, is name valid. Now, similarly to the dbus example in the beginning, we create a helper function which creates a name object. And down below, we have the conditions to check whether the minimum length of 3 is satisfied, whether the maximum length of 40 is satisfied. And we have a helper function which gets the length of the constant string that we provide. And in the end, we just check whether it starts with a capital A. Our macros, which make sure that all the conditions are satisfied. And then in the end, we can start implementing our structure persons. So I know it may seem convoluted, but imagine that you have a data coming from database or you want to save data to database. I think it makes sense that they satisfy some of the conditions and tell the programmer, even at compile time, that your data will not be saved properly at the place you are trying to save unless some conditions are satisfied. So we make sure that the types that we provide to the person constructor of a name of a type name, surname, age, and expenses. And by utilizing this concept, we make sure to just forbid the implicit converters that have. Then we have our getters. And finally, for all of this to work, because the contract is a class which includes private members, we need to declare our person contract as a friend. So I was always surprised that friend is a keyword in C++, and I wanted to give it more meaning in order to remember where to use it properly. So I came with a tiny story, is that if someone wishes you well and worries about your well-being, it is your friend in your real life. As this person contract is worrying that person is formatted it and constructed in the proper way, it's indeed its friend. So friend class person contract is a friend of the person, just like someone in real life. And wrapping up, this executes properly because of all of the constraints have been satisfied, and the program terminates returning 0. So I think it's now time to make a conclusion and to try to understand what we learned from the CCI. So I think we got a good understanding that CCI is a powerful tool in developers' arsenal. It allows to shift some work from runtime to the compile time. It can also serve to wrap low-level facility functions into higher abstractions with applied constraints. We also noticed that the contracts can also serve to express programmatically the meaning of descriptive text of a particular software artifact. So for example, if you have a UML diagram, and if you really get into the contracts and try to force it as much as possible, I think that you can pretty successfully describe even a UML diagram. Therefore, it can serve as a signature of a software artifact. The resulting binaries are no bigger than their counterparts without CCI, which is always important in our case, because we don't want to trade performance. And therefore, I would not put the title of supercharging. It would not have been supercharging your IPC programs. And we also need to make sure to understand what CCI is not. So it's not a universal tool that needs to be used everywhere. The examples presented here were more of an academic nature, where I tried at each parameter to put a concept and just to prove a point. So we need to be smart about it and use it where we really need it. Techniques presented here can be also done with other C++ techniques. I think this is pretty much obvious, because as we know in C++, you can do one thing in many ways. And in the end, it always falls on the responsibility of a program to decide where to utilize it. So I hope you enjoyed this talk and this presentation. And I will be more than happy to take any of the questions that you have. And I would encourage you to come to the microphone if any one of you has questions.
Thank you very much. It was a very interesting talk. I was gonna say it's always great to see somebody like trying to modernize kind of like a legacy, like more kind of like C style interface with something more modern and safer. So that's always awesome to see. One thing I was wondering about, and so in the case, like in most of the cases when we're kind of building, excuse me, when we're building up the concepts, it seems like we're kind of like, we've taken the approach of kind of like defining contracts first and then kind of combining those together into a concept. One thing I was wondering about, I think in a lot of situations, we have situations where, and actually it was kind of interesting. I didn't actually know that you could like use Sphene for like a variable template like that. That was actually kind of cool. I hadn't seen that before. But one thing I was wondering about, in many cases, I think we could probably use requires clauses for a lot of those things as well. Like instead of kind of, basing it on top of Sphene, since we're using concepts anyway, just kind of use the dedicated requires syntax. I was just kind of wondering if it was just personal preference or if there was some specific reason.
Yes, I agree. So basically what he's proposing that the CCI pattern can be clamped in concept implementation. So you can clamp those two Cs. Yes, that is a valid approach and it can be done. But I just wanted to just show that I believe that the code that is easy to understand is that when you read it aloud to a cat or a dog, it can be said in the least words possible in the plain English. So this seemed like a very good flow to go. Or maybe you could create like, use the contracts as the interface and apply them in different concepts. So it just, I guess, to the preference of the programmers. But I agree wholeheartedly that those two C's can be clamped down in one C.
Right,
From
right.
CCI to become CI.
Right. Well, and actually, so I'm fine with having, like, I kind of like having the composable contracts and can be used to be made concepts. That makes sense. But I guess what I was kind of wondering about is like, instead of like for some of the things, instead of kind of enforcing the contracts via like specialization and Sphene and stuff like that, I think we could probably use requires clauses inside of a lot of those contracts as well. It might just kind of convey what's being done a little bit. Like for I think most people in this room, people are familiar with seeing Sphene code, so like it makes sense to us, but it might just be a little bit more readable. But yeah,
I agree. Thank you.
So great talk.
Thank you.
But I noticed you focused on sort of the sender side of the interface, and there's also the receiver side. And there's a very good, I think there's a good analogy here with the broader C++ concepts that's also being discussed here. Do you see that as sort of the analog for the runtime receiver side verification of preconditions?
Yes, and the source code that I actually, when I was building this, I built both sides, like the receiver and the sender. But during the talk, when I started preparing, I saw that it was going to overshoot and just lose the whole story. But also, I think this could be applied from the receiver side as well, because there are many constraints that need to be taken up on. I took an image without even specifying a format, but what happens if I don't want a JPEG, I want something else, or I provide a bitmap? So I guess this pattern could be also applied a lot from the receiver side, maybe even more than from the client side. So it was a bit clamped down for the purposes of this talk.
So what does the runtime cost look like then? Because this looks entirely compile time, and how would you verify that in sort of an IPC scenario without a runtime component? How would you verify your preconditions on the receiver side at runtime?
So the condition on the runtime. Well, some of the conditions, I believe, they would have to be evaluated during runtime. It's, of course, impossible everything to make in the compile time, because this was more of like an academic example. So I just have a simple executable. OK, I want green channel. I'm done. I can make everything at compile time. But if in the real case, where we cannot verify everything at compile time, we have to revert back to the facility of C++ of checking them at the runtime. Did I understand correctly what you asked?
I think I need to talk to you after this.
Sure.
Yes, thank you.
Yeah, you're welcome. So, any other questions? I guess we are done.